any footprints on my wood floors in my van.
All right, let's see what we had with this one. Second part. So first we're going to do it with the switch open. So what was with this switch open, what's the amps going to be anywhere?
120.
Oh, amps.
You're assuming, huh? It's going to be 0 amps with it open. Now what's the voltage between A and H? 120, because that's our source voltage. And what about between D and G? Because if my division is here, anything on just this side is going to be 0. Anything on just this side is going to be 0. Anything across this will give us a reading. So we'll say D to G, that's going to be 0. D and E.
0.
So in this same, that's going to be 0. F and G. 0. B and C.
120.
Now I'm across, 120. Good. So now let's check it with this switch closed. With this switch closed, our potential difference now moves. Okay? So as that potential difference moves, anything on this side will be just that.
Yep.
Anything on this side will be anything on this side will be 0. Anything on this side, just this side, will be also 0. But we have a new problem going on. So the amps, what's the amps going to be? What'd you guys get? 0.3. Wow, did that change? We're going to come back to this. A and H. So between A and H, that's my source voltage. That shouldn't change. This is important because if you're working in an air conditioner and you do not have source voltage, it's not going to do you any good checking for voltage throughout the system, is it?
No.
It's like, oh wow, my light bulbs are out. Let me go get my meter and start checking to see if I have voltage to my light bulb. Well, do you have voltage to the house or the neighborhood or the breaker or the plug or the switch or anywhere first, right? Right? So we want to make sure you have source voltage. So then let's check between D and G. So here between D and G, what do we have? 120. 120. So I got my full voltage, 120. But now between D and E,
60.
ooh, only 60 here. Interesting. Let's go ahead and check F to G. That's also 60. What if I added 60 plus 60 together? 120. So this is called a series circuit. You guys have heard of a series of unfortunate events? You have one event that you get out of, and then you're going right into another unfortunate event, and then you leave that unfortunate event and into another one, and out of that one into another one, and life goes on, right? This is series. We go into a switch, out of a switch, into a load, out of a load, into a load, out of a load, home to line 2. It's a series. It's all in the same line. Into, out of, into, out of. This is a series circuit. These loads are wired in series. When you have loads wired in series, they have to take the source voltage and it has to divide them between the load, between the resistance. Okay, so between both of them, we get 120. So they take that 120 and they divide it up. Now our watts are the same, so the resistance is the same for each of these. So we divide it up, say, okay, you get 60, you get 60. There we go, we're good to go. Does that make sense? Yeah. Right, so we're going to come back to this in just a second. B and C, that's across our switch here. It's all on this side, so it's for sure, without a doubt, going to be 0. All right, so it's pretty well the opposite, except for our source voltage stays the same. That shouldn't change. Cool, huh? All right, so let's go back to a few things. Our light bulb had approximately 240 ohms of resistance. We calculated, right? So that means this one has about 240 ohms, and this one has 240 ohms. And it's resistance to electron flow. Resistance to electron flow. So in this circuit, by adding another circuit, I've added more resistance. So what's the total resistance between D and G?
480.
Good. 480 ohms of resistance. So what did my overall resistance do? Go up. So I have more resistance to electron flow. At the same voltage, what happens to my speed of electron flow? Slows down. So there's more resistance to the flow. That means my flow will slow. Yes. The amps have been slowed down. I have more resistance. So the amps dropped. My amperage is only what, 0.3? My volts is 120. So what's 120 times 0.3?
360.
Is that right? 0.3? I don't.
It's 36.
You have calculators.
We believe you, guys.
You can either use your app or just simply take 0.3 times 120.
It's 36.
36? Everybody get the same answer?
Yeah.
36 watts. Amps, 0.3 times volts, 120. Only 36 watts of power. So, even though they're two 60-watt light bulbs, how many watts of energy am I using? 36. I'm using less. I'm using less watts. But I have twice the bulbs. They're using less watts. Was it brighter with two bulbs?
Should be.
But was it brighter?
No.
You looked at it, right? You were there, weren't
It
you?
wasn't.
They were a lot duller, weren't they? Is that not interesting?
That kind of makes sense because if you got a house and you got a lot of bulbs on, you're gonna
Ah.
pay more money.
We're going to talk about it. But in the house, as you turn more lights on, does it get duller and duller? So that's wired a different way. So what happened if I added another light bulb?
You're really going to slow it down.
Do we have another light bulb on that board?
No.
You're a fan.
Oh, we do have another light bulb. If we look up, there's another light bulb. So guess what we're going to do next? We're going to put them 3 light bulbs. So now wire 3 light bulbs. And we're going to wire these in what method? Series.
Hopefully no one will share that.